Assalamualaikum warahmatullahi wabarakatuh. We are group 3 from set B. So this is our simulation for current model. So firstly, we have data table. This data table is used for the profile type: 1 hole, 2 hole, 4 hole, and 6 hole. The data table is inserted to the source. Okay, after the source, we have extrusion and then pre-cooling. At pre-cooling, we have workplace because in the question, it stated that there are 2 stations that operate manually, pre-cooling and packaging. So at the 2 stations, we put the workplace and we use worker pool and worker, so the worker can operate the workstation manually. After that, we will go through the assembly station. This assembly station is used to creating a batch size for after cooling workstation. At the question, it stated that after cooling have a batch size of 6 profile. So at the assembly station, we set 6 profile. After the after cooling, it will be dismantled by the dismantle station, and then we use assembly station and assembly station to create a batch size of 250 in 4 container for the heat treatment. So the first assembly station 1, is 250. We create the batch number 250, and then we use the assembly station 2 to create the 4 container. So we will go to the heat treatment, chemical treatment, and oven drying. After oven drying, the 250 profile in 4 container will be dismantled by the dismantle station 1 and dismantle station 2. Dismantle station 1 will dismantle the 4 container, and dismantle station 2 will dismantle the 250 profile. So we will go through the powder coating conveyor individually. At the powder coating conveyor, the question stated that it has a processing time of 110 meter per hour. So we converted it to meter per second, and we will get 0.0305 for the speed. And it also stated that the conveyor can carry 14 profile at a time. So we set the capacity of the conveyor to 14. Okay, after that, we'll go to after the powder coating conveyor, it will go to the oven drying conveyor. And then for the assembly station 3, the last assembly, it is used for the packaging. Because the packaging is individually profile are packed into packages of 6 profile each. So at assembly station 3, we set to 6 profile. 3. This is because there are 2 conveyor, so we will have 2. 3 from the upper conveyor, 3 from the bottom conveyor. So for 7 days of processing, the output we will get 3,499. So there are several assumptions that we made for this simulation. The number 1 is the worker efficiency is 100%. And then all the workstation have an error of 5%. Error of 5%. 95% of availability. So the failure rate is 5%. Same like others workstation, 5%. So the next assumption is the duration for the container to transfer for building 1 to building 2. We neglect the duration. We neglect the duration of the transfer of the part transfer from building A, building 1 to building 2. We also neglect the assembly and disassembly station. We do not put any processing time on the assembly station, and we also do not put processing time on the dismantle station. The last assumption that we made is worker do not need foot path. So on the worker pool, we set the travel mode to move freely within the area. So the worker do not need the footpath to go to the workstation.
Assalamualaikum and good day. My name is Anuar bin Jamaludin. Now I will continue with verification and validation. Verification is how we translate the real system into our simulation model. As we can see on the screen, there are 9 processes involved in this model. For each process or workstation have their own process time and batch size allowable range. According to Metal Core Sedan Berhad, for the first process, which is extrusion, the process time is only for 1 minute. Next, for the second and ninth process, which is pre-cooling and packaging, is the only 2 processes were automated by the worker, and the process time for pre-cooling session is using Erlang. For the third process, which is after cooling, the process time is 5 minutes. Before going to this process, the parts have to go assembly session to assemble, as the batch size allowable range is only to 4 to 8 profiles. The fourth process is heat treatment. The process time is 5 hours and 30 minutes. Before going to this process, the parts have to go 2 different assembly stations and 1 dismantle station, as the batch size allowable range is 200 to 300 profile per container and 1 to 4 container. The next process is chemical treatment. The process time of this process is only for 1 hour. The sixth process is oven drying. The process time of this process is only for 30 minutes. For the 7 and 8 process, the part process while on the conveyor. The process time for both conveyor is 110 meter per hour. So if we convert to meter per second, it will get 0.03055 meter per second. The batch size allowable range for powder coating process while on the conveyor is 6 to 16 profiles, and the batch size allowable range is not stated for oven drying process. The last process is packaging. The process time of this process is using normal. So before going to this process, the parts have to go to assembly station, as the process detail is individual profile are packed into package of 6 profile each. Now we go to validation of the model. To validate the model, we compare on the weekly historical data by Metal Core Sedan Berhad with our simulation model. Currently, the production rate of Metal Core Sedan Berhad for 8-hour shift is about 240 package, or 3,360 per week on an average. The company operates on 2 shifts daily. Now we simulate our model. When we simulate our model for 7 days, we get the number of output is 3,499. So there is not a big difference with our simulation model compared to Metal Core Sedan Berhad. So we can conclude our simulation model is valid and also can represent the real system. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Alif Najmi bin Marzian, and I will present you about data collection. So as you see, the simulation lasts a total of 7 days of the simulation. The simulation's output on the 7th day is 3499 as shown in the diagram below. Next, the total work in progress WIP. The proportion of work in progress for each workstation in the system shown in the table. It displays the proportion of time that the workstation must wait until for the next station to finish before moving on the next batch. The workstation pre-cooling has the greatest proportion of WIP, which at 58.15%, and the workstation powder coating and oven drying process on conveyor have the least proportion of work in WIP at 0%. The percentage of machine time is really in use is known as machine utilization. The table shows the statistic in workstation which is the percentage of time spent on each workstation. The workstation of heat treatment has the greatest proportion of machine usage, is at 65.43%, while workstation pre-cooling has the lowest number at 2.15%. Next, improvement throughput by 3 alternative value. A perform experimental study to determine the optimal batches size throughput to improve production line. Based on 3 different models that have been studied, each test has a unique outcome and analysis. Our objective is to determine the optimal batch size. The minimal range, medium range, and maximum range are 3 different values that we experiment to optimize the production line. In terms of adjustment and result, each assembly station, such as aftercooling and heat treatment, has a role to play. The cumulative statistical after 7 days throughput for minimum range, medium range, and maximum range are 2566, 3583, and 3469. The best result based on quantity is minimum profile that accumulates a total of 3583 per 7 days. Next, model assumption. All the assumptions listed below were based on actual system output and observation conducted. First, worker efficiency is 100%. Second, all workstations have an error of 5%. Third, duration for container to transfer to a different building is negligible. Fourth, assembly and disassembly station process time is neglected. And lastly, workers do not need footpath. They can move freely within the area. Thank you.